Hi guys, welcome to our video lecture series of Laplace transforms. So we are continuing the inverse transform lessons, and in previous lessons we talked about some properties of inverse transform. So we talked about the inverse transform of a function when s is multiplied by f of s, that is given by the derivative of f of t plus f of 0 multiplied by delta t. So this f of t is found by using this f of s, and the Laplace inverse transform of function of s divided by s is given by integral 0 to t the Laplace inverse of given f of s dt, or we can write it as integral 0 to 2 function of t dt. So this function of t is the inverse transform of this function of s. And then we talked about the shifting properties. There is first shifting and second shifting property. So the first shifting property is Laplace inverse of function of s plus a is equals to e raised to the power negative at multiplied by the Laplace inverse of function of s. So what does this f of s plus a means? I will recall here. F of s plus a means that some function like say s plus a, s plus 3, or s minus half. This is the function of s plus a. This is the type of function of s plus a. So I write here so you don't get confused. And then the second shifting property, that is about the heaviside step functions. So the property says that the Laplace inverse of e raised to the power negative as multiplied by f of s is equals to function of t minus a multiplied by unit step function of t minus a. So this property deals with functions unit step functions, and this is for unit step functions. We solved some problems on these properties, and now we will move on and we will take some more examples on the second shifting property of Laplace transform, so that you guys may understand it well. Let's say a question is we have to find the inverse transform of s e raised to the power negative s over 2 plus pi e raised to the power negative s divided by s squared plus pi squared. So we have to find the inverse transform of this function, and I can write this function in two parts, that is s e raised to the power negative s over 2 over s squared plus pi squared plus Laplace inverse of pi e raised to the power negative s squared plus pi squared. So if we recall the second shifting theorem, it says that the inverse of e raised to the power negative as times f of s is equals to function of t minus a multiplied by u of t minus a. So the first thing we need to do is we write the function in this form. So first of all, take this function. So Laplace inverse of s e raised to the power negative s over 2 divided by s squared plus pi squared. So I can write this function as Laplace inverse of e raised to the power negative s over 2 multiplied by s over s squared plus pi squared. So now this function has gained the form of the second shifting property. So now we can find a here easily. A is equals to 1 over 2. If we compare this with this, we can find it easily. A is equals to 1 over 2, and the function of s is equals to s over s squared plus pi squared. Now we need to take the inverse transform of this function to get f of t, and then we will find f of t minus a. So the inverse transform of this function s over s squared plus pi squared will be equals to cos of pi t, and this implies that the function of t minus a is equals to cos of pi multiplied by t minus a, and we know that a is equals to half, so the function will be cos of pi into t minus 1 over 2. So this is our f of t minus a, and now we know that the Laplace inverse of the whole function, that is negative e raised to the power negative s over 2 times s over s squared plus pi squared, will be equals to f of t minus a, that is cos of pi multiplied by t minus half, and then unit step of t minus a. So this is inverse transform of the function, and now we will take the inverse transform of the other function. So the other function is Laplace inverse pi e raised to the power negative s divided by s squared plus pi squared. We will proceed with the same procedure, and we will write this function in the form of the second shifting property, that is e raised to the power negative s multiplied by pi over pi s squared plus pi. So if I compare this e raised to the power negative s with the second shifting property, I will get a is equals to 1. A is equals to 1, and f of s in this case is pi over s squared plus pi squared. So now I will find the inverse transform. So the inverse transform of pi over s squared plus pi squared is very simple. That will be equal to sine pi t. Now the next step is to find the function of t minus a. So function of t is sine pi t. This implies that function of t minus a is equals to sine of pi times t minus a, and now the shifting property will be applied. So e to the power negative s multiplied by pi over s squared plus pi squared will be equal to the function of t minus a, that is sine of pi into t minus a multiplied by the unit step of t minus a, where a is equals to 1. So I will replace the a with 1, so this implies that sine pi of t minus 1 multiplied by u of t minus 1. So this is the inverse transform of this function, and now the combinedly we can write it as s e to the power negative s over 2 plus pi e raised to the power negative s over s squared plus pi squared, and this is equals to cos pi into t minus half, cos of pi into t minus half multiplied plus multiplied by unit step of t minus half, and then plus sine of pi into t minus 1 and unit step of t minus 1. So this may be the final answer, or you can even simplify it further, like applying the trigonometric properties to simplify these functions. So we can do that, simplifying and then taking something common and solving the problem. You can leave it here. Up till here it's okay, it's fine. This is the final answer, that is cos pi multiplied by t minus half into unit step function of t minus half plus sine pi of t minus 1, and that is multiplied by the unit step of t minus 1. That is the answer. So thank you guys for watching the lecture, and this lesson will be very helpful in your studies, and you can take more examples from the books. And if you are having some problem, you can ask in the comments, and don't worry about the questions. So thank you guys, thank you for watching lectures.